Hello there and welcome to the Sleepumentary channel. Tonight, as you lie still and let your body slow down, we're going to open a very special door together, a journey into distances so vast they can make the human mind pause. This video is called Light Years, the Distance That Breaks Our Brains. But don't worry, the goal isn't to overwhelm you. It's to gently expand your imagination so you can drift into sleep, wrapped in a quiet sense of awe for the universe. You've heard the term light year hundreds of times, but very few people ever stop and truly feel what it means. That light, the fastest thing we know of, still needs an entire year to cross a single stretch of cosmic space. And that distance becomes the measuring stick for galaxies, for stars, and for the ancient history of the sky you look at each night. When you understand what a light year really represents, you begin to realize that every point of light in the night sky isn't just a star. It's a message sent from the past. Its light began traveling long before you were born, sometimes long before our entire civilization even existed. So for now, just let yourself soften. Take a slow, deep breath, and allow me to guide you into a gentle journey where science becomes a lullaby, and the universe becomes a story that carries you into sleep. A familiar distance that isn't simple at all when you lie down at night. Letting your breath soften and slow, your eyes, whether open or closed, tend to drift towards something far away. Maybe it's the night sky outside your window, or maybe it's just a memory of the stars you saw when you were a child. Yet there's an interesting truth. Most of us have heard the phrase light year, but almost no one has ever paused long enough to truly feel what it means. In daily life, we're used to distances we can physically reach. A road a few hundred meters long, a drive of a few kilometers, a flight of a few thousand. These numbers make sense because they belong to our bodies, our habits, our perception. But a light year is nothing like that. It is a measurement that makes our intuition useless. A distance so immense that the mind loses its footing. A number that, when understood correctly, becomes, as Carl Sagan once said in Cosmos, somewhere, something incredible is waiting to be known. It is within these numbers that exceed our understanding that we begin to feel the vastness of the universe, along with the gentle stillness it brings. And so, on this journey, you can imagine yourself as a relaxed passenger drifting along a soft flowing river of knowledge. We're not going to hurry. We're not going to push. We're simply going to explore why a light year, a term that sounds almost casual, is actually the key that unlocks the unimaginable scale of the cosmos. Human beings are born with an intuition for distance shaped by experience. We know how long it takes to walk a kilometer. We know how far a car can travel in an hour. That intuition works beautifully here on Earth, our tiny planet only 12,242 kilometers from one side to the other. But when we take that intuition and point it outward, into space, it collapses instantly. The distance from Earth to the Moon is 384,000 kilometers, a number already far beyond our ability to picture. But imagine walking that distance. You would need more than 10 years, without sleep, without rest. Suddenly, the gap between everyday experience and the scale of the universe becomes clear. The distance to the Sun, 150 million kilometers, is even more impossible to grasp. It's so large that familiar units like meters or kilometers lose all meaning. No human intuition can feel what 150 million kilometers is. But light can. Light travels at 300,000 kilometers per second, so fast that in a single heartbeat, it can circle the Earth 7.5 times. It's almost unbelievable that anything can move that quickly. But this discovery forced astronomers to adopt an entirely new way of describing distance. They measure space by the distance light travels. A light year is not time, it is the distance light covers in 1 year, 9,460,000 kilometers, 9,460,000,000,000 kilometers. No human brain can truly visualize that number, but it is the smallest unit the universe requires us to accept if we want to understand it. As Albert Einstein once wrote, the most incomprehensible thing about the universe is that it is comprehensible. The universe is so vast that the very fact we can describe it with mathematics is already a miracle. When we look at the night sky, we aren't just seeing stars, we are seeing the past. Light takes time to travel, and so every point of light is a slice of history. The moon you see is the moon 1.3 seconds ago. Sunlight shows you the sun as it was 8 minutes ago. Sirius, the brightest star in our night sky, sent its light 8.6 years ago. Vega, the star of ancient legends, is sending you light that began its journey 25 years ago. And if you spot Betelgeuse, the huge red star on Orion's shoulder, the light reaching your eyes tonight has been traveling for 50 years, which means if Betelgeuse has already exploded into a supernova, you still wouldn't know. You may be looking at a star that no longer exists. There may be no image more beautiful for understanding a light year than this. When we look at the sky, we're looking into an archive of time, a museum of light suspended above us. Every star is an ancient letter, written tens, hundreds, even thousands of years ago. And this is what makes the light year both enchanting and challenging to the human mind. It forces us to abandon intuition and embrace scientific imagination. We cannot feel 9 trillion kilometers with our bodies, but we can feel it with our awareness, through the quiet astonishment of realizing that the entire universe, from galaxies to galaxy clusters, operates across distances like these. When we understand the light year, we understand a small part of how the cosmos works. And in that understanding, as Neil deGrasse Tyson once said, we are part of this universe, we are in this universe, but perhaps more important than both of those facts is that the universe is in us. A light year doesn't make us insignificant, it makes us deeper. It lets us look at ourselves with humility, but also pride. Because only one small species on one small blue planet could even imagine distances big enough to break its own brain. And in that moment, quiet, gentle in the middle of the night, we suddenly feel connected to something far greater, yet still tender, warm and welcoming. If you're ready, we will continue this journey slowly, softly, building an intuition for light, for space, and for the distances that stretch far beyond human imagination. But for now, just remember one simple truth. Every light year is a story about time, space, and ourselves. From familiar distances to the edge of human intuition. As this journey begins, we won't plunge straight into the universe. We won't speak of millions or billions of kilometers. Instead, we return to what is familiar, the distances your body understands through footsteps, car rides, and the small daily orbit of human life. No matter how advanced our telescopes or spacecraft become, humans still carry within them a biological intuition for space, an intuition that only works within the boundaries we've walked, touched, and lived. Imagine yourself taking a calm, unhurried walk, listening to the soft rustle of leaves beneath your feet. 1 kilometer, 10, maybe 15 minutes on foot, easy, a straight path, a line of trees along the roadside, a dome of sky above you. Everything here is within your sight, your reach, your understanding. If you're driving, a few dozen kilometers take only about an hour. Humans are naturally skilled at sensing distances within this range. Nothing unusual, nothing overwhelming. These numbers are gentle, intuitive, and approachable. They're the small building blocks of our spatial intuition. But as we begin to stretch that measuring stick, something strange happens. Our intuition tries to cling to the world it knows, but the numbers grow too fast. Think of the United States, a vast country stretched across multiple time zones. Traveling from the East Coast to the West Coast, you cross more than 4,500 kilometers. By car, it takes several days. By plane, 6 hours. This is a large enough distance for your body to feel that the world is far bigger than the streets around your home. And even though the number is large, we can still sense it. We've flown before, taken long road trips, looked at maps, seen a continent stretching wide beneath us. Then we reach Earth's circumference, 40,075 kilometers. A number you cannot touch, but one you can imagine if you remember that an airplane needs about 40 hours to fly around the planet. If you tried to walk it, it would take nearly 2 full years. Now the number begins to blur. Your intuition starts to loosen, as if holding onto a thin rope between the familiar and the uncertain. But this is just a gentle transition. We're still playing in Earth's backyard. The distance from Earth to the Moon, 384,000 kilometers, is the first true leap beyond what human intuition was designed to handle. No one has ever walked that distance. No one has driven there to compare. No one has ever experienced that much emptiness with their own body. 384,000 kilometers opens into a void for which the brain has no matching experience, no concrete image to anchor itself to. We can only rely on metaphors. If you drove at highway speed without sleeping, without stopping, it would take you more than 5 months to arrive. But even that comparison quickly collapses, because the real distance is so large that any everyday example feels forced. This is the first moment where intuition surrenders. The distance to the Sun, 150 million kilometers, is where every value we once understood about kilometers becomes meaningless. No one can imagine 150 million kilometers. There is no comparison that allows our senses to grasp it. And this is where astronomers had to admit that human units of measurement simply do not work in the universe. Kilometers are no longer the right language. It's like trying to describe the width of the ocean by counting your footsteps. The unit is correct, but the scale is not. Astronomer Edwin Hubble once said, "The universe is not only expanding, it is expanding beyond the limits of our imagination." That distance, 150 million kilometers, is the first threshold where imagination begins to drift away from reality. In cognitive science, this is called the spatial intuition limit. The human brain evolved only to handle distances useful for survival, a few meters for hunting, a few hundred for spotting predators, a few kilometers for moving across territory. Beyond a few dozen kilometers, intuition begins to fade. Beyond hundreds, it grows vague. Beyond hundreds of thousands, it dissolves completely. And here is the fascinating part. As intuition fails, the mind becomes more free. When we're no longer confined by familiar experience, the imagination opens, no longer needing real-life images to hold on to. It steps into a more abstract world, but one that is strangely poetic. The distance to the moon tells us we live in a three-dimensional space far larger than we ever sensed. The distance to the sun shows us that the solar system is an enormous stage, where every object floats at vast separations from one another. It is ironic and beautiful. We live in a universe where emptiness, not matter, is the dominant feature. And when we grasp this, we understand why scientists had to create the concept of the light year, not to make things complicated, but because the universe cannot be described in units meant for human beings. As Neil deGrasse Tyson once said, "The universe is under no obligation to make sense to you. Space wasn't built for human comfort. Space simply is, vast, empty, and stretched so far that every attempt to visualize it collapses. But in that collapse, science reveals its beauty. It allows us to step beyond intuition and move closer to truth. When we face numbers too large to comprehend, we are touching a part of the universe our ancestors never even imagined." And so next time you hear someone say 150 million kilometers, smile softly. Because you know that kilometers cannot contain such vastness. You know your intuition will reject the number, but you also know that where intuition breaks, understanding begins to bloom, like a small flower opening under the night sky. Hold on to that gentle feeling, because in the next part of our journey, we will shift into a new language, the language of light. And that is when every door truly begins to open. Why we need the light year. When familiar numbers begin to melt away from our intuition, when kilometers are no longer a language capable of holding the vastness of space, that is the moment we're forced to find another way to speak, a way to describe the universe without letting the human mind shatter under the weight of endless zeros. And right at that boundary, where intuition fades but imagination opens, astronomers found a solution that is gentler, more elegant, and almost sacred in its precision: the light year. It is strange to think that an entire infinite universe could be described using the motion of something that seems so small, so delicate. Light. The same light you see every day in the sky. The light that reflects off your eyes from a lamp. The light of a sunset settling softly on the horizon. Something familiar, gentle, almost fragile, and yet it is the most powerful messenger the universe has ever sent to us. And when you understand the speed of light, you will understand why it became the measuring stick for the entire cosmos. Light travels at 300,000 kilometers per second. Pause for a moment, not to grasp it with physical intuition, but to feel it with the quiet of your mind. In a single second, light travels farther than you have in many years of your life combined. In 1 second, it can circle the Earth 7.5 times. If you stood beside a beam of light rushing past you, it would leave you so quickly that your eyes could not follow it. Your mind could not hold on to it. The universe did not choose light as its language by accident. Its speed is almost absolute, unchanged no matter where you stand, on which planet or in which era. Einstein described light as a pillar of the structure of space-time, an ultimate limit no object with mass can ever exceed. In the universe, nothing carries information faster, nothing is more useful for measuring distance. But what makes light extraordinary is not just its speed, it is its relationship with time. Did you know that when you look at the sun, you're not seeing it as it is right now? Sunlight takes 8 minutes and 20 seconds to reach Earth. If the sun disappeared this very moment, you would not know for more than 8 minutes. From the instant you open your eyes and look up at the sky, you are seeing an image, a story, sent from the past. In a world where everything feels instantaneous, messages sent instantly, images displayed immediately, reflexes firing in milliseconds, it is difficult to accept that even light, as impossibly fast as it seems, still needs time to travel. And because it needs time, Every distance in the universe carries a shadow of history. A light year, therefore, is not merely a distance, it is time, frozen into light, a story that has crossed darkness to reach us. But why do we need it? Why not use kilometers, or any familiar unit? Let's return to a simple example. When we describe the distance from Earth to the Sun, 150 million kilometers, kilometers become awkward, clumsy. The number is too large to become an image in the mind. But if we say the Sun is 8 light minutes away, everything suddenly feels clearer. 8 minutes is something you've experienced millions of times. You know how long it is. You know what it feels like. You can sense it. The universe was not created to fit human intuition. But by turning distance into time, something our minds can sense far more easily, astronomers gave us a remarkable tool, a bridge between two worlds, the small finite world of human beings and the vast infinite world of space. So the light year is not just a scientific quantity. It is a beautiful metaphor. The distance information must travel through darkness. When you look at a star 10 light years away, it means the light left that star when you were still a child. When you look at a star 100 light years away, the light began its journey when people who have long since passed were still alive on this earth. And when you look at galaxies millions of light years away, that light comes from a time before humans existed, when Earth was still young, covered in molten rock and primordial oceans. As Carl Sagan said, we're a way for the cosmos to know itself. Measuring with light years allows the universe to make sense. It allows it to tell its own story. And so, every time you hear the phrase light year, remember that it is not just a precise scientific number, it is a breath of the universe. A step taken by light through darkness, a slice of time touching your eyes. It tells you that space is not empty. It is a vast book, and light is its pages, each one requiring time to open. As you relax into this narration, allow your mind to imagine. Every light you see has traveled a journey so long it cannot be pictured. It crossed the cold emptiness of space, slipped past cosmic dust, glided through magnetic fields, and bridged unimaginable distances just to arrive here within your eyes. That is why we need the light year, not to make things harder, but to remind us that the universe is far larger than we ever dreamed, and that every time you look up at the sky, you're looking into the past, a past written in light. If you're ready, then in the next part, we will go even deeper, from light seconds to light minutes, to the full journey of one light year, and begin building a new intuition of our own. The concept of space-time, light, information from the past. And once we understand why light becomes the measuring stick of the universe, we begin to step into an even more wondrous realization. Light does not only carry information about distance, it carries time. It is the universe's stream of memory, flowing endlessly through space-time until it reaches our eyes. Like an ancient letter wandering through the void, light never arrives from the present, but from some past version of the universe. The cosmos does not send us what is happening. It sends us what has already happened, from a few seconds ago to hundreds of millions of years ago. And so the next part of our journey becomes a beautiful blend of time and space. A gentle lesson that when we look up at the sky, we never see the present. We're gazing into an archive of light, a museum suspended across the vaulted ceiling of night. To begin, let's return to something close and familiar: the moon. Light from the moon needs only 1.3 seconds to reach your eyes. This means that every time you look at the moon, you're seeing it as it was, 1.3 seconds ago. The delay is tiny, barely noticeable, yet it forms the foundation for understanding that all light carries the imprint of time. If the moon were to vanish instantly, though such a thing will never occur, you would not know until more than a second later. In a world where everything feels immediate, the moon quietly reminds us that the universe moves on a rhythm far slower than our human senses. Then we go a bit farther, to a star beloved by almost everyone who has looked at the night sky, Sirius, the brightest star. Light from Sirius takes 8.6 years to reach Earth, meaning that when you see it sparkle, you're seeing a version of it from 8.6 years ago. If you are 30 years old, the light you see tonight actually left Sirius when you were 21. And if you look again tomorrow, you will still be seeing the past, because the light that departs tonight will not arrive for another 8.6 years. The universe never allows us to see the present. It only lets us see history, written in beams of light. Now let's travel even farther to Vega, once the North Star thousands of years ago because of Earth's shifting axis. Vega is 25 light-years away, which means the light you see tonight departed long before you were born. If you're 20, it left 5 years before your existence. If you're 40, it began its journey when you were just a newborn. You and Vega have never existed in the same moment, yet light bridges those two moments together, a fragile, unwavering bridge stretching across time. That is why Carl Sagan once said, "We live in a universe of unimaginable antiquity." Vega gives us a sense of the flow of time in a way no creature on Earth ever experienced before. And then we come to Betelgeuse, a colossal red star nearing the end of its life. It is 550 light-years away. The light you see from Betelgeuse tonight began its journey in the 15th century, when ancient empires still stood, when the first explorers were only beginning to redraw the map of the world. If Betelgeuse has already exploded into a supernova, we still wouldn't know. What you're seeing might be a ghost image, the picture of a star that no longer exists, whose final message has not yet reached us. The universe keeps its secrets not through silence, but through distance. Once we accept this, a soft yet profound understanding appears. Every glance at the sky is a journey through time. No time machine needed, no science fiction. Your eyes are the oldest, most perfect time travel instruments humanity has ever had. You are seeing the universe not as it is, but as it was. You are looking at history from 1 second ago, history from 10 years ago, history from hundreds of years ago, and when you observe distant galaxies, history from millions or even billions of years ago. There is no observation we make of the universe that is present. All of it is memory drifting through space-time. In the stillness of night, when your heartbeat slows and your breath steadies, this truth reveals a strange and gentle beauty. Every star becomes a message from an ancient age. They show us that the universe is not just vast across distance, it is deep across time. Space and time are inseparable. A distance is a duration. A single glance is a brush with the past. And once you understand that, you will never look at the night sky the same way again. You will see it as an old film reel playing slowly, very slowly. Stars retelling their lives through light. The universe narrating its history through darkness. And we, tiny beings on a blue planet, somehow have the ability to comprehend all of this. That is the quiet miracle of science. As you relax into this narration, remember something gentle. Every time you look at the night sky, you are looking into the history of the universe, a history not written in words but written in light. Not sitting in books, but drifting through space-time. Not still, always moving across billions of years. If you're ready, then in part 5, we will attempt something very few people have ever done. We will build a new intuition, from light seconds to light minutes, to light days, and finally to the full journey of a light year. From light second to light year, building a new intuition. Once we begin to see the universe as an archive of light, where every star is a fragment of time's memory, a gentle question starts to form. If light always tells us the story of the past, how do we feel the distances within that story? How do we build a new intuition? A smoother way of understanding numbers far beyond anything human instinct was designed to grasp. To answer that question, we must begin with the smallest step, the light second. Just as we learn to swim by letting our feet touch the bottom before drifting into deeper water, building a cosmic intuition also begins with small, gentle steps, and then gradually extending the scale until it reaches the vastness of space. A light second is the distance light travels in 1 second, 300,000 kilometers. In a moment so brief you haven't even blinked yet, light has already crossed a distance greater than anything you will ever travel in your entire lifetime combined. If Earth were shrunk to the size of a round table, light would race across it faster than you could perceive its path. The light second is the foundation of every astronomical distance. Tiny, simple, yet immensely powerful. When we stretch that interval into a light minute, we make a small multiplication. 60 seconds x 300,000 kilometers, about 18 million kilometers. This distance is equal to roughly 45 trips around Earth's circumference. Imagine this. If you stood at one point on the planet and light ran around the Earth like a marathon runner, then in just 1 minute it would complete 45 laps. But the beauty here is not the absolute numbers, it is the way they swell so quickly. Each new unit of time opens a door into a space the human eye has never seen. Then we arrive at a light hour. A light hour equals 60 minutes x 18 million, billion kilometers. This distance is nearly as wide as Earth's orbit around the Sun. A single hour of light travel can take you across planetary boundaries, deep into regions where even Earth's magnetic shield can no longer protect you. But allow your mind to drift with this gentle realization. From 1 minute to 1 hour, all it takes is multiplying by 60. Yet suddenly we're on a journey of over 1 billion kilometers. This exponential rhythm makes the mind tremble, not from fear, but from soft astonishment. A light day expands the scale again. 24 hours x 1.28 billion + 25.9 billion kilometers. This distance is far beyond the orbit of any planet in the solar system. A light day carries you into the cold, shadowed regions where icy objects drift like silent ghosts. In a single day, we have traveled so far that every connection to everyday life becomes meaningless. Here, human intuition dissolves once more. But that is the beautiful part. When intuition dissolves, imagination becomes completely free. Then we move to a light week. A light week equals 7 days, x 25.9 billion km, 181 billion kilometers. Now we are far beyond what most of us can visualize. A light week takes us out of the solar system entirely and into the dim spaces where only faint dust clouds remain. If the solar system were a single leaf in a vast forest, then after a week of traveling at light speed, you would have left that forest behind and now stand in a boundless field where every direction fades gently into darkness. A light month is the first truly dramatic leap beyond all attempts at mental grasp. 30 days, x 25.9 billion km and 78 billion kilometers. This distance is nearly the width of the Sun's gravitational influence over small icy bodies. A light month brings you to the hazy threshold between a star system and interstellar space, where the Sun's pull weakens and the cold ocean of the galaxy begins to appear. At this point, human understanding must surrender. No one can feel what 778 billion kilometers means. Nothing in human experience can anchor such a number, and yet, by imagining it, we enter the purest landscape of the mind, a place where imagination has no limits. And finally, we arrive at the light year. 12 light months, 9.46 trillion kilometers. This number is so enormous it exceeds every natural boundary of human imagination. It is a measurement created not for us to picture, but simply to accept. A light year is no longer a number, it becomes a concept, a unit crafted for the universe itself. It is the distance light travels over the course of a full year, a year in which flowers bloom and fade, seasons arrive and depart, while light never pauses, not even once. When we say a star is 10 light years away, we're saying that its light has travelled tirelessly for 10 full years through darkness to reach our eyes. When we say a galaxy is 1,000,000 light years distant, we're saying that its light began its journey before humans existed. When Earth was still raw rock and ancient seas, the scale from light second to light year is a ladder of exponential expansion. It shows us that the universe is vast not only in distance, but in concept. The universe was not designed to match human intuition. The universe was designed to stretch it, to challenge it, to expand it, to teach it how to love the infinite. And as you relax into this journey, your mind expands with it. You don't need to understand every number. You only need to feel the rhythm of light, a distant whisper of the cosmos. Real-world examples of the limits of light. After our journey of building intuition from the light second to the light year, you may have begun to sense something soft yet profound. Light, though fast to the point of seeming absolute, is still not instantaneous. It always needs time, and it is precisely this property that makes the universe a place where every piece of information drifts slowly, so slowly that at times it feels as though space is deliberately keeping its secrets. And right now, as we step into a more practical part of the story, we must recognize a simple truth. The universe is so vast that even light, the fastest thing we know, becomes slow. To feel this limit clearly, let's begin with the closest place humans have ever touched: Mars. Mars is our neighbour, not too far from Earth on the scale of the cosmos. At its closest approach, it is about 54 million kilometres away. At its farthest, due to the way our orbits drift apart, it can be nearly 400 million kilometres distant. And because light can only travel at 300,000 kilometers per second, the signals we send to the rovers on Mars, those small, patient explorers crawling across the red planet's rocks, never arrive instantly. The delay ranges from 2 to 22 minutes depending on the relative positions of Earth and Mars. This means that if you were driving a rover, when you press a button, it takes about 10 minutes for that command to reach Mars, and then another 10 minutes for the rover's response to return. A simple task, like asking the rover to raise its robotic arm, becomes a half-hour conversation stretched across space. Every command is like a message sent into darkness, and every reply is like an echo returning from very far away. We cannot drive the rover in real time. It must think for itself, decide for itself, avoid rocks, judge danger. Humans cannot intervene quickly enough, and in that delay, we discover the first truth. The universe is not designed for fast communication. But that is only the beginning. Let's travel much farther to the most distant human-made object from Earth, Voyager 1. Voyager 1 was launched in 1977 and has now left the solar system, drifting into interstellar space. Its distance from Earth is so immense that the radio signals it sends, though travelling at the speed of light, take about 24 hours to reach us. Imagine, you ask a question today, you receive the answer tomorrow, and that is only one direction. If you want to ask again, you will wait another 24 hours. Every conversation with Voyager becomes a slow, ghost-like dialogue across time, requiring a patience that only humanity's curiosity can sustain. Voyager is a beautifully humbling reminder that no matter how hard we try, the universe keeps its distance. It never answers immediately. It does answer, but only after time has passed. In a way, this delay makes the cosmos feel deeper, quieter. Now let's go a little farther still, to Cassini, the spacecraft that returned the most breathtaking images of Saturn humanity has ever seen. Cassini spent more than a decade orbiting Saturn, photographing its delicate rings, its icy moons, and the massive swirling storms at its poles. But Saturn is so far from Earth that each image Cassini sent back took more than an hour to reach us. 1 hour is not long by human standards, but at the speed of light, the fastest speed in the universe, 1 hour is enough for light to travel over 1 billion kilometers, and every image Cassini returned was a slice of Saturn's past, a moment already long gone by the time it reached our eyes. When the spacecraft dove into Saturn's atmosphere for its final descent in 2017, even the very last beam of light that recorded its fate took many tens of minutes to return to Earth, as if the universe wished to hold the moment a little longer before letting us see it. These three examples, the Mars rovers, Voyager 1 and Cassini, are gentle, beautiful reminders that the universe never permits instantaneous communication. Nothing can outrun the speed of light. There are no shortcuts. There are no exceptions anywhere humans have touched or glimpsed. The universe moves at its own pace, and that pace is slower than we expect. Even when humanity builds its most advanced technology, sends its strongest signals, and reaches out with all its ingenuity, we still have to wait. Not because our machines are weak, but because space-time itself sets limits no one can cross. These limits teach us humility. They teach us to accept that some things cannot be changed, no matter how hard we try. And they teach us that distance is a fundamental part of the universe's character. Yet within this slowness lies a special kind of beauty. Every signal we receive, no matter how delayed, is proof that humanity has touched something far away. Every image, every transmission, every faint reply is a small miracle, showing that even in a universe where light itself feels slow, human beings keep moving forward. Delay is not an obstacle. It is the price of seeing what has never been seen. And so, as we continue our journey, we come to an even deeper realization. If light takes hours to travel even within our own solar system, what happens when we talk about stars, civilizations, worlds beyond our sun? Interstellar communication is almost impossible. As we look back on the journey we've taken, it becomes easy to notice one thing. Even within our own solar system, our tiny cosmic backyard, light has already become far too slow for our desires. Signals sent to Mars must wait tens of minutes. Voyager 1 whispers its answers from interstellar space only after a full day. Cassini returned images over an hour late. and these delays turned every attempt at communication between humans and the cosmos into half-finished conversations drifting through darkness. But all of these examples, no matter how distant they feel, still occur within the boundaries of the solar system, a small neighborhood of the universe. When we step outside toward the nearest stars, we begin to understand a quiet, bittersweet truth. The universe is vast not only in space, but in time, and so vast that every civilization becomes an isolated island in an ocean of light. Let's begin with the Sun's closest neighbor, Proxima Centauri, 4.24 light-years away. The number sounds modest, especially now that we've grown used to trillions of kilometers. But placed in the context of communication, a gentle yet merciless truth appears. If we sent a message to Proxima Centauri today, the beam of light carrying our question would need 4.24 years to reach it. If someone there replied immediately, their answer would need another 4.24 years to come back. In total, 8.5 years for a single question. Imagine asking a distant civilization, "Hello, are you there?" Then waiting 8.5 years to hear a faint reply, "We are here." A greeting stretched across nearly a decade. In that time, a child on Earth could finish elementary school. A nation could change its leader. A spacecraft could travel from Earth to the edge of the solar system. And that, remarkably, is only the nearest star. Now imagine the civilization lives not 4 light-years away, but 50 light-years away. That distance spans a vast region of space, nearly the width of a major section of our Sun's galactic neighborhood. At 50 light-years, sending a question. 50 years, receiving an answer. 50 years, 100 years for the simplest dialogue. It is no longer a message between two individuals, no longer a conversation between two scientists. It becomes an exchange between two generations. The person sending the message would die before the reply arrived. The one answering would be speaking to people not yet born when the question was sent. Raise the distance to 100 light-years, and the exchange stretches across 2 centuries. A conversation that begins in one era would only be answered in an entirely different one, with different technology, different languages, perhaps even a different world. We would have to communicate through descendants. The universe does not refuse us. It simply moves too slowly for human lifetimes to keep pace with its rhythm. And this delay affects more than communication. It affects understanding itself. If a civilization 50 light-years away looked at Earth today, they would be seeing Earth in 1975. A world of the Cold War, rotary phones, and leaded gasoline, unaware of the internet. At 100 light-years, they would see Earth in 1925, when radio was new and humanity had never glimpsed the surface of Mars. At 1,000 light-years, they would see a world where humans still believed Earth was the center of the universe. And if they wished to warn us about something, or reply to a message humanity once sent, that response would take 1,000 years to arrive. A civilization may vanish before its message ever reaches us. We live in a universe where information travels more slowly than societies evolve. Sometimes when we look up at the night sky, we feel as though everything is still. The stars fixed in place, constellations unchanged for thousands of years. But the truth is different. Space is full of motion. Stars orbit the center of the galaxy. Planets circle their suns. Galaxies race toward one another. But we never see these motions in real time. We see the motions of the past. Every civilization, if any exist, sees Earth not as it is, but as it once was. Yesterday, last century, or last millennium. Instantaneous communication between star systems, therefore, is not just difficult. It is nearly impossible. not because the universe refuses us, but because the structure of space-time turns every call into a distant echo. And in a way, this truth carries a very gentle beauty. It gives us a rare experience. The stillness of the universe is not emptiness. It is the stillness of slow time, a reminder that not every place follows humanity's hurried rhythm. The universe has its own tempo, long, deep and slow, like the breath of some vast living being. And perhaps it is this slowness that moves us when we gaze at the night sky, because in that slowness we see ourselves small yet steady, a species just curious enough to send greetings into places where no one may ever hear them. As you relax into this story, remember that the space between stars is not a barrier, but a reminder of the universe's immensity, and that every signal humanity sends, whether it takes decades or centuries to reach anywhere, is proof of a dream that never fades. The desire not only to know the universe, but to be heard within it. In Part 8, we will step into an even deeper layer, the physical limits of interstellar travel. If communication between stars is this difficult, then how much harder is the journey itself, for bodies, for spacecraft, for hope? The physical limits of space travel. And now that we've seen how communication between stars is so slow it becomes almost impossible, another thought gently rises in the mind, soft as a breeze drifting in from the far edges of imagination. If we cannot speak to them in real time, what happens if we try to go to them? This is the question humanity has carried for centuries, a longing both proud and fragile, the desire to cross every boundary and touch the stars. But as we step deeper into the structure of the universe, we begin to understand that some boundaries are not drawn on maps. They are woven into the fabric of space-time itself. The universe does not challenge us only with distance. It challenges us with speed, a limit woven into the laws of physics, the speed of light. The speed of light, 300,000 kilometers per second, is not just a beautiful number describing the quickness of photons. It is the universe's ceiling, the maximum speed at which any form of information can move. Einstein described it as an unbreakable boundary, a permanent speed limit of the cosmos. Nothing with mass can ever reach that speed, let alone surpass it. The reason is not weak technology or inadequate materials. The reason lies in Einstein's most famous equation, E mc2. As an object with mass accelerates toward the speed of light, its relativistic mass increases. The faster it goes, the heavier it becomes. Near the speed of light, its mass approaches infinity. And to push an object with infinite mass, you would need infinite energy. The universe does not provide infinite energy. Even our imagination struggles to picture such a thing. So any spacecraft we build, Voyager, Starship, or some design from a distant future, as long as it carries mass, will always be limited. It can be fast, very fast, but it can never touch that 300,000 Hellenoscans boundary. Yet humanity is not a species that gives up easily. We've imagined every possibility. Massive starships, sails pushed by beams of light, and even technologies that might outrun light itself, faster than light travel, or FTL. You may have heard ideas such as warp drive, bending space itself, wormholes, shortcuts through space-time, the Alcubierre metric, a theoretical model where space contracts in front and expands behind, letting a ship surf on distorted space. These ideas are beautiful, almost poetic, and deeply inspiring. They let us dream of a day when humans might travel to the stars like characters in science fiction. But Each idea encounters impossible physical barriers. Warp drives require exotic matter, material with negative energy density, the opposite of any known substance in the universe. Wormholes require enormous energy to stabilize, and even then, they collapse almost instantly. These models exist in mathematics, but nature does not implement them. We can write the equations, we can dream. But the universe whispers softly, "Not yet." And when we return to reality, we encounter a gentle but unmistakable truth. Even reaching the nearest star, Proxima Centauri, is beyond our current capabilities. Try to imagine it. If a spacecraft traveled at 1% of the speed of light, it would take 424 years, 10% of the speed of light, 42 years, 20% of the speed of light, 21 years. But even 10% of light speed is nearly impossible today. No engine can achieve it. No power source is compact and strong enough. And most importantly, no shielding exists that could protect a ship from microscopic dust at such speeds. Each grain would strike the hull like a hypervelocity bullet. Interstellar travel is not only a problem of speed, it is a problem of surviving in a universe where every danger is magnified exponentially. But rather than discouraging us, this truth opens something beautiful. The universe is not closed to us. It simply teaches us a slower rhythm. Humans can reach the stars, not with our bodies, but with our minds. Telescopes, robotic missions, mathematical models, all of them carry us deeper into the universe's essence. Some journeys require no engines, only patience. Some doors open not through technology, but through understanding. And perhaps the real beauty of being unable to travel faster than light is this: the stars remain just distant enough to inspire us, yet close enough to study. As you relax into this narration, feel the gentleness of this truth. The universe will not always allow us to go where we wish, but it will always allow us to understand what lies there. And sometimes, understanding is its own kind of travel. In Part 9, we will widen our view even further, not just to the nearest stars, but to the structure of an entire galaxy itself. How vast is the Milky Way? And how large is the observable universe? The vast portrait of the universe. As we close the chapter on the physical limits of space travel, on the realization that even the nearest star lies far beyond the reach of today's technology, a feeling both small and curious touches the mind. If a journey to our closest neighbor star is already so difficult, then just how vast is the universe beyond? This is the moment when science stops being merely numbers and equations. It becomes a painting unfolding gently in your mind, soft, immense and luminous, like a piece of music whose melody is written in light. To begin, let's return to the largest home humanity has ever belonged to, the Milky Way, our galaxy. The Milky Way is about 100,000 light-years across. This means that even if we traveled at the speed of light, the absolute limit, the boundary that nothing can surpass, it would still take 100,000 years to cross it. 100,000 years, a span longer than the entire history of human civilization. When that beam of light began its journey, Earth may have been home only to small groups of early humans learning how to craft simple stone tools. And by the time that beam reached the far side, our entire civilization could be transformed in ways we cannot imagine. We live inside a vast spiral disk, a whirling structure of stars, dust and gas, and our sun is just a tiny point among 100 to 400 billion other stars. And it isn't only the size of the galaxy that overwhelms the mind. Even the sun's path through it moves on a scale far beyond human time. The sun takes 225 to 250 million years to orbit the center of the Milky Way. The last time the sun stood where it is now in its galactic journey, dinosaurs did not yet exist. Earth belonged to primitive reptiles wandering ancient landscapes. There were no humans, no flowers, no birds. Each orbit of the sun is a galactic year, a unit of time so deep and slow that all of human history is just a tiny dot within that immense path. Let this thought settle gently. Humanity has existed for only 0.01% of a single galactic orbit, a grain of dust in the timeline of a spiral giant. But even our galaxy, vast as it is only a small part of a universe far greater still. The portion of the cosmos that humans can observe with our telescopes, the observable universe, is about 93 billion light-years across. Not 93 trillion, not 93 quadrillion, but 93 billion light-years. If light left the farthest visible edge at the dawn of time, it would still be travelling toward us now. This number does not mean the universe is only that large. It only marks the limit of what we can see. Everything beyond expands faster than light can reach us, its glow forever hidden, like an ocean stretching endlessly beyond the horizon. Within this observable universe are roughly 2 trillion galaxies. Each galaxy holds tens or hundreds of billions of stars. Each star may host planets. Each planet may hold stories no one has ever heard. If each galaxy were an island, then the universe would be an ocean with 2 trillion islands. And we have explored only one, our own. This feeling is not meant to make you smaller, but to make you expand. Every distant galaxy is a gentle reminder. The universe has no obligation to be small enough for your imagination. It is your imagination that must grow wide enough to love its immensity. And when we reach even larger scales, the final wonder appears. The largest structure in the universe, on scales of hundreds of millions of light-years, galaxies are not scattered randomly. They arrange themselves into colossal strands, giant filaments of light, woven into a vast cosmic lattice resembling biological cells, soap bubbles, or the neural pathways of an enormous brain. Between these glowing filaments lie immense voids, regions so empty they stretch for hundreds of millions of light-years without a single star. Imagine a delicate, shimmering web stretching across the cosmos. Earth, the Sun, the Milky Way. We're just a tiny point on one thin thread of this immeasurable tapestry. Science calls this structure the cosmic web, but when you look at it, it feels like something more sacred, as if the universe is sketching a portrait of itself using galaxies as strokes of light. And then, when we pause for a moment, we recognize a truth both gentle and profound. The universe is far too vast for humans to ever reach in full. Not because we aren't trying, not because we lack technology, but because the very fabric of space-time places the journey beyond the lifetime of any civilization that lives only a few decades. And yet, within this impossibility lies a quiet beauty. It is precisely because we cannot reach the entire universe that every small discovery becomes precious. It is because we cannot understand everything that each thing we do understand feels like a wonder, and it is because we cannot go everywhere that simply looking up at the night sky becomes an act filled with meaning. The universe does not give us everything, but it gives us enough beauty to keep us looking up for the rest of our lives. In part 10, we will descend into a deeper philosophical mystery born from this vastness. If the universe holds trillions of galaxies and countless planets, why haven't we met another civilization yet? The Fermi paradox. Why haven't we seen aliens? As we zoom out from the vast cosmic picture, 2 trillion galaxies, each containing hundreds of billions of stars, a strange and quiet feeling begins to rise, a feeling soft as breath, yet deep as the ocean. If the universe is this enormous, are we truly alone? This question has echoed in the human mind ever since we first learned to look up at the sky. But at the moment we realize that our galaxy is just one tiny glowing point in an immense cosmic web. The question becomes impossible to ignore. If there are so many planets, so many chances for life, why haven't we met anyone? This is the mystery the physicist Enrico Fermi once whispered. Where is everybody? And that small question became one of the greatest paradoxes in modern science, the Fermi paradox. To begin, let's step back and look at what science already suggests. Life is not rare. It could emerge on countless worlds, under different conditions at different times. Earth-like planets are being discovered more and more often. Liquid water may exist in far more places than we ever imagined. The chemistry of life is not particularly special. The universe seems biological, teeming with potential, overflowing with opportunity. If our galaxy alone contains hundreds of billions of stars, then why would life choose only one planet? Or more precisely, why are we the only ones hearing our own voice? The Fermi paradox does not claim aliens do not exist. On the contrary, it begins with the assumption that many civilizations should exist, and yet we still have no sign of them. What stands in our way? A gentle but unyielding truth found in the earlier chapters: distance. Distance is not just large. Distance is time. Distance is separation. A civilization 100 light-years away is not only far in space, it is far in time. A single message between 2 civilizations would take a century just to say, hello. A civilization 1,000 light-years away, we are seeing them as they were in the 10th century. They are seeing Earth during the age of medieval kingdoms. Neither of us knows the other's present moment. Any light we send today will reach their sun in the year 3024, or much later, and their light, if they sent any, may already be on its way but will not reach us for hundreds or thousands of years. Communication between civilizations is not just difficult, it is nearly impossible on human timescales. But distance does not merely delay signals, distance causes them to disappear. Radio waves traveling hundreds of light years fade into cosmic background noise, the microwave whisper left behind by the Big Bang. By the time a signal arrives, it may be indistinguishable from the hiss of the universe, and if a civilization lasts only a few thousand years, a tiny flicker in cosmic history, the chances that 2 civilizations exist at the same moment, close enough, with the right technology, and both pointing antennas in the correct direction, is incredibly small. Like 2 candles lit at opposite ends of an endless desert, each may shine brightly for a moment, but they never see each other. In a universe 93 billion light-years wide, with space expanding and light traveling slowly, perhaps life is not rare. What is rare is the meeting, and this is the heart of the Fermi paradox in the gentle, sleep-soft way we explore it here. It's not that humanity is alone in the universe, it's that we are isolated by the very fabric of space-time. The galaxy may be full of life. Civilizations may whisper in the cosmic dark. They may have sent signals long ago, but the light is still gliding through silent space. Or perhaps it passed by long before anyone was listening. And perhaps somewhere, on a distant world, another civilization is looking up at their night sky, wondering the exact same question: where is everybody? But perhaps the beauty of this paradox lies not in the absence of alien civilizations, but in the way it turns our gaze back to ourselves. Earth is small, yet vibrant. Humanity is rare, and therefore precious. Our cosmic isolation may simply be temporary in the endless history of the universe. The Fermi paradox does not bring loneliness. It brings a kind of cosmic quiet, a silence deep enough to let us hear our own voice clearly. Under a long night sky, filled with stars, perhaps the most beautiful thing is not finding someone else out there, but realizing that even without hearing another civilization, we still have each other, we still have our own light to send. And in that vast silence, every message humanity sends, even if no one ever hears it, becomes a tiny monument to our most enduring hope, that we're not just learning about the universe, but longing to be heard within it. In part 11, we'll turn toward a softer, more philosophical direction. What happens to the human mind when it understands its own smallness? And why does that smallness not diminish our meaning, but deepen it? Philosophical meaning, small, but not insignificant. And as we leave the Fermi paradox behind, as the question, where is everybody, fades like a distant echo in the mind, a gentle calm begins to flow into the quiet space within us. Because after everything, perhaps the fact that we haven't met another civilization does not bring despair, but instead opens a vast room in which we can look back at ourselves. In that silence, a very soft realization appears. We are small in the universe, but that smallness does not make us insignificant. When you look up at the night sky, it seems as though you're gazing at a still painting. The stars appear frozen, the constellations unchanged, the darkness stretching endlessly. But science tells us something different. When you look at a star, you're not seeing it as it is now. You're seeing light that left long ago, light that has traveled tirelessly across space to meet you in this exact moment. The moon you see is the moon of 1.3 seconds ago. Sirius is the Sirius of 8.6 years ago. Vega is the Vega of 25 years ago, perhaps before you were even born. And Betelgeuse is the Betelgeuse of 550 years ago, from a time when medieval Europe still shaped the world. This means every time you look up at the sky, you're touching the past, decades, centuries, even millennia old. No time machine, no advanced technology, just two open eyes and a heart willing to wonder. So what does this say about us? In a universe 93 billion light-years wide, where galaxies stretch like endless islands and time flows like a river without an end, the human being is just a tiny point, a brief moment, a passing breath. And yet, we are extraordinary in a way the universe rarely expresses. We understand the universe, or at least we're learning to. We do not have the power of stars nor the lifespan of galaxies, and yet we've found a way to decode light, decode time, decode physics, decode space. Forces operating on scales trillions of times larger than ourselves. A species that lives for only a few decades has written equations describing the curvature of space, the motion of photons, the birth of galaxies from ancient clouds of gas. A species with a brain weighing barely 1.5 kilograms can imagine a universe so large it breaks every familiar reference point. This brings us back to Carl Sagan's famous words that linger like a soft lantern in the dark. We are a way for the cosmos to know itself. When you understand the light year, when you understand that ancient light is falling into your eyes, you're not simply learning a scientific idea, you are opening a philosophical doorway. The universe is not only out there, it is also within you. in your ability to think, to imagine, to question. In every cell you carry carbon atoms forged in the core of a star. In every breath, you inhale material shaped by supernova billions of years old. In every dream, you reach distances your feet could never walk. You don't just live in the universe, you are a piece of it. Once you deeply understand the light year, your way of seeing the world begins to shift. Everyday worries, the to-do lists, the deadlines, the small anxieties, begin to soften like ripples on a pond beside an endless ocean. Not because they disappear, but because you now hold a wider, gentler perspective, one that lets you be kinder to yourself. You start to see that your life, though brief, is a beautiful fragment in the vast symphony of space-time, a symphony in which every note, every choice, every breath, every moment of love adds depth to the melody. From this vantage point, the smallness of the human being stops being a reason for despair. It becomes a quiet inspiration. We are small, and so we are curious. We are fragile, and so we cherish. We do not know everything, and so we learn. We cannot touch every star, but we can understand their light. And in the journey from ignorance to awareness, from darkness to illumination, humanity becomes something remarkable, a creature that wonders where it stands in the universe and falls silent before its beauty. The universe does not require us to be large to give us meaning. It only asks that we look up and listen to the whisper of light. In the deep night, as you drift towards sleep, let one gentle thought stay with you. You are small, but you are the window through which the universe watches itself. You are small, but you carry within you the history of stars. You are small, but large enough to understand that the light of centuries past is resting on your shoulders, telling you the story of the entire cosmos. And every time you look up at the sky, even for a moment, you are touching something far beyond the limits of imagination. You're conversing with the past of the universe through the eyes of the present. And so, after a long journey through scales that defy intuition, past distant stars, unbreakable physical limits, and philosophical questions soft as mist yet deep as the mind can reach, we return to the most familiar place of all, your own heart. You have travelled through a light second, a light hour, a light year, and distances vast enough to bend your thinking. You have stood inside the Milky Way, 100,000 light years wide, looked out into a universe 93 billion light years across, then gently lowered your gaze back to Earth. Small, warm, and holding you in this very moment, you've listened to the whisper of light, of the past, of stars that died hundreds of years ago, whose final photons are only now brushing against you like a greeting that arrived late but still found its way. And in the end, you discovered something wonderfully soft. You're small, but you're not insignificant. In your eyes, the universe reflects itself. In your mind, carbon atoms forged in ancient stars suddenly learn how to think. In the questions you ask, the cosmos hears the echo of its own story. Carl Sagan was right. We are a way for the cosmos to know itself. You are that doorway, a window opening into the darkness, a small but steady point of light in the vast ocean of space-time. So now, let your shoulders loosen. Take a slow, deep breath. Feel your body drifting into a state as weightless as light. Tonight, as you fall asleep, remember that the entire universe, with its billions of galaxies and uncountable stars, is not far away at all. It is present in every breath, every heartbeat, every quiet thought, wishing you a deep, peaceful rest, a night filled with calm, a gentle journey carried on ancient streams of starlight. And when you wake tomorrow morning, may the world feel wide and beautiful in an entirely new way. Sleep well beneath the sky that belongs to you.